All right, in this video, we're going to talk about finding inverse functions and their graphs. So first I have the example of this linear function, f of x equals 2x minus 1. So to find the inverse function, the first thing I'm going to do is replace f of x with y, since those two things mean the same thing. Then I'm going to remember that inverse functions have the property that their x's and y's are switched. So I'm going to switch the x and y in my equation. X equals 2y minus 1. Now I'm going to solve for y so that I can get y as a function of x. So I'll do that first by adding 1 to both sides. And so on the left-hand side, I get x plus 1. On the right-hand side, I have 2y. And then I need to divide both the sides of the equation by y. So on the right, I just end up with y, and on the left, I'll have x over 2 plus 1/2. Now I'm just going to rewrite this using my inverse function notation. So f inverse of x equals 1/2 x, which is the same as x over 2, plus 1/2. And I'm writing it in slope-intercept form so that it'll be a little bit easier to graph. So now let's graph these two. So I'm going to pop in some graph paper here. Now, whenever we're drawing inverse functions, we should always draw in the y equals x line first, since inverse functions are reflections over the y equals x line. So that's y equals x. Now, my original function was y equals 2x minus 1. So that is a line with a y-intercept of -1 and a slope of 2. So I'm going to do -1. I'm going to rise 2, run 1, rise 2, run 1. I'll do a couple points in the opposite direction, and I'll just try to draw a nice straight line. So that's my original function, f of x. My inverse function, right, is 1/2 x plus 1/2. Now that y-intercept of 1/2 is a little annoying to graph, so I can use the properties of inverse functions to get some other points as well. So for example, this point at 0, -1 is going to be reflected to -1, 0. This point at 1, 1 is going to have to be the same. And this point is at 2, 3. That'll be reflected to 3, 2. And so I can see that I have a slope of 1/2. And so I put in a couple more points and I draw my line. I can see that these two inverse functions are clearly reflections across the y equals x line. Now, I notice with both of these, with my original function, f of x, the domain and range was all real numbers, since this is a line. And that's also true for the inverse. So this is for this is for f and f inverse. They both have domains and ranges of all real numbers. So let's do another example where a domain and range is not all real numbers. So we're going to say, let f of x equal the square root of x plus 1. All right, we're going to find the inverse function. So it says find f inverse of x. So this is number 2. So we'll start with the same process. We change f of x to y. We switch our x and y. So x equals the square root of y plus 1. And now I need to solve for y. So to get rid of this square root, I'm going to have to square both sides of my equation. So that means that on the left-hand side, I'll have x squared. And on the right-hand side, the square root and the square will cancel. And that'll leave me with y plus 1. Subtracting 1 from both sides gets me x squared minus 1 equals y. And now that I've solved for y, I can rewrite this as f inverse of x equals x squared minus 1. Now, let's try to think about these graphs. So I'm going to graph my f of x first. First, remembering to draw in the y equals x line. So I have to remember that the square root of x plus 1 is just a transformation of the parent function. my parent function is the square root of x, which starts at 0, 0, and goes off in an increasing direction. So the square root of x plus 1 is a translation left 1 unit. So I have the point 0, 1. I have the point, negative 1, 0, 0, 1. Then I can plug in, if I plug in 3, I'll get 2. All right, and there is my f of x. Now, before I graph this inverse function that I found, I'm just going to reflect the points, right? So this point here, negative 1, 0, is going to go to 0, negative 1. This point here of 0, 1 is going to go to 1, 0. And this point here of 2, 3 is going to go to 3, 2. And they should intersect on the y equals x line. So that's not a nice integer point, but I can put a point there. So notice that this is giving me, just by reflecting those points, half of a parabola. I could go in and graph the other half of it just to kind of see, right? And this is the graph of x squared minus 1, right? It's just x squared, which is a parabola, shifted down 1 unit. But we don't graph the whole thing because we only want to graph the part that is a reflection of the original function. So that means we're going to talk about the domain and range. The original function, the square root of x plus 1, from our graph, the domain is all values greater than or equal to negative 1. So that's negative 1 to infinity. Or we could write it as x is greater than or equal to negative 1. The range is all y values that are positive. So we could write that as 0 to infinity, or we could write it as y greater than or equal to 0. So that's the domain and range for f of x. The domain and range for the inverse, since x and y are switched, are just going to be switched. So if the domain for f is negative 1 to infinity, that means the range for the inverse is negative 1 to infinity. And if the range for f is 0 to infinity, the domain for the inverse is 0 to infinity. And so now if I look at my graph, this domain tells me only to plot these points where the x is greater than 0. And I don't want to graph the other part of the parabola because that's not part of the domain. All right, let's try one more example. Oops. So say I'm given f of x equals x squared minus 3. Actually, let me change this a little to make it a little different. We're going to do f of x equals x minus 3 squared. And we want to find the inverse. All right, so we'll do our same process. Y equals x minus 3 squared. Switch your x and y. X equals y minus 3 squared. And now I need to get rid of that square, which means that I'll have to square root both sides of my equation. So we end up with the square root of x equals y minus 3, since the square root and the square cancel. But now I have to be careful because anytime I take a square root, I need to put in plus or minus. And so I have y equals plus or minus the square root of x, and by adding 3 to both sides, we get plus 3. But now this is not a function, meaning it won't pass the vertical line test. That plus or minus means that it won't be a function. So let's graph this parabola and see what's happening. So let me pop in my graph again. All right, so x minus 3 is a parabola shifted to the right 3 units. So 1, 2, 3, there's my vertex. I could find that the y-intercept is going to be 9, which means that this has to go up fairly steeply. Okay, and that's my f of x. So now let's plot the y equals x line. And let's reflect our points. Okay, so this point, 3, 0, is going to go to 0, 3. This point, 4, 1, is going to go to 1, 4. And this point, 2, 1, is going to go to 1, 2. And I can draw this sideways parabola, right? This green sideways parabola is not a function since it will not pass the vertical line test. Any vertical line will hit it twice, right? And so we can write this as the inverse. We just won't call it a function this time. Now, if we change the problem slightly, say the original problem said that f of x equals x minus 3 squared, so the same problem, but it specified that x was less than or equal to 3. So it's saying that we're only going to graph the part of the function where x is less than 3. So that means that I'll graph the same parabola, but I'm only going to graph the left-hand side of it. So looking up here at this graph, I'm going to highlight it in yellow. This part, the left-hand side of the parabola, is where f of x has x less than 3. So I'm just going to graph that part of the parabola. Then I have to see which part of the sideways parabola corresponds to it. It's going to correspond to the lower part of the parabola. And we'll see why in a second, but I'm going to graph that now. It's going to be this little part, right? And the reason is that for f of x, they've restricted the domain. They said instead of letting the domain be all real numbers, let the domain just be x is less than or equal to 3. Then the range, if I look at my function, is y greater than or equal to 0. It's all positive values. So that means that the inverse function is going to have a switched domain and range. The domain will have to be x greater than or equal to 0. The range will have to be y less than or equal to 3. And so looking at that, this part of the sideways parabola that I've drawn has x greater than or equal to 0, but y always less than 3, right? It's always below this y equals 3 line. All right, and so we just have to choose which side of the parabola when we have a restricted domain.